Audio Jungle.
In the previous chapter, we provided a foundational understanding of AI, defining it as the simulation of human intelligence in machines. We explored the history of AI, its various types, and essential AI techniques, such as machine learning, deep learning, natural language processing, computer vision, and robotics. In this chapter, we explore the fundamentals of machine learning, including supervised and unsupervised learning. We introduce neural networks, the basis of deep learning, and their real-world applications like image recognition and natural language understanding. Finally, we discuss the training process and optimization techniques for neural networks. Machine learning and deep learning. 1. Machine learning basics. Machine learning is a subset of artificial intelligence that focuses on enabling computers to learn from data and improve their performance on specific tasks without being explicitly programmed. The core idea is to develop algorithms that can identify patterns and relationships in large datasets, allowing the machine to make predictions or decisions based on the learned patterns. Supervised learning. In supervised learning, the algorithm is trained on labeled data, where each input is paired with the corresponding correct output. The model learns from this labeled data, and can then make predictions on new, unseen data. Unsupervised learning. Unsupervised learning involves training the algorithm on unlabeled data. The model tries to find patterns and structures in the data without any predefined output labels. Training data. Training data is the dataset used to train the machine learning model. It consists of input data and their corresponding output labels in the case of supervised learning. The model learns from this data to make accurate predictions on new, unseen data during the testing phase. 2. Neural networks. Neural networks are a fundamental component of deep learning, a subset of machine learning. These networks are inspired by the human brain's structure and consist of interconnected nodes or neurons organized in layers. Input layer. The first layer receives the input data, which is then passed through the network for processing. Hidden layers. Between the input and output layers, there can be one or more hidden layers. These layers extract complex features and representations from the input data. Output layer. The final layer produces the model's predictions or outputs based on the processed data. Neural networks work by passing data through the layers, and the connections between neurons have weights that determine the strength of their influence on the output. The network adjusts these weights during training to minimize the prediction errors and improve accuracy. 3. Deep learning applications. Deep learning has enabled significant breakthroughs in various applications. Image recognition. Deep learning models excel at recognizing objects and patterns in images, leading to advancements in fields like computer vision, facial recognition, and autonomous vehicles. Natural language understanding. Deep learning has revolutionized natural language processing, allowing machines to understand and interpret human language, enabling applications like language translation, sentiment analysis, and chatbots. Autonomous vehicles. Deep learning plays a critical role in developing self-driving cars. These models process sensor data from cameras and other devices to make real-time decisions on navigation and safety. 4. Training and optimization. Training neural networks. The training process involves feeding the model with training data, and adjusting the network's weights iteratively to minimize prediction errors. This process continues until the model achieves satisfactory performance. Backpropagation. Backpropagation is a key algorithm used in training neural networks. It calculates the gradients of the model's error with respect to each weight, allowing the model to adjust the weights accordingly to improve its predictions. Optimization techniques. Various optimization techniques are used to fine-tune neural networks efficiently, such as stochastic gradient descent, SGD, adaptive learning rates, for example, ADAM, and regularization methods to prevent overfitting. In summary, machine learning, powered by neural networks and deep learning, revolutionizes AI by enabling computers to learn from data and perform complex tasks previously thought to be exclusive to human intelligence. The applications of machine learning are diverse, ranging from image recognition to natural language understanding, and it continues to drive advancements in AI technologies. In this chapter, we discussed the basics of machine learning, including supervised and unsupervised learning. We introduced neural networks and their applications in image recognition and natural language understanding. Finally, we covered the training process and optimization techniques for neural networks. In the next chapter, we'll explore the practical applications of AI in various industries, including healthcare, finance, transportation, and retail. Discover how AI is transforming these sectors and its impact on society. Join our channel to learn more about the fascinating world of science and technology and subscribe for the latest updates on AI and other cutting-edge topics. Don't miss out on the future of innovation.